Leo Francis, URK 24 CO 2005. This is experiment number 4. Here, I import the pandas number and matplotlib and I load the P5 CSV dataset. And first, I start by removing columns that have more 30% of missing values because such columns can reduce the quality of the analysis. Then for categorical data, I replace the missing values with the most frequent value, which is called mode. And for numerical value, I use the median since it is robust to outliers. And next, I convert the categorical data variables into numerical format using encoding so that the model can process them. After that, I define the target variable, which is price, and I convert it into a binary from values above the median are labeled as 1, and the values below the medians are labeled as 0. So this converts the problem into a binary classification task, and I normalize all input features so that the mean of 0 and the standard deviation is 1. This ensures the stable and faster learning. I also add a bias term which helps the model to fix the data better. And then the next we have perceptron model training. Here it is one of the simplest types of neural networks used for binary classification. So the perceptron works by taking a weighted sum of features, applying a threshold function to classify output as either 0 or 1. Initially, all weights are set to 0. For each data point, the model predicts an output. If the prediction is incorrect, the weights are updating using a learning rate. This process continues for multiple iteration called epochs. During each epoch, I also count the number of misclassifications, which helps in tracking how well the model is learning. And the second thing is finding the best epoch. While training, I store the number of errors of each in each epoch. The epoch with the minimum number of errors represent the best performance to train the model. This indicates that the model has learned the most accurate decision boundary at that point. This step helps in understanding when the model performs optimally. So the final weights and confidence visualization. After the training uh, is complete, I display the final weights learned by the model. And these weights represent the importance of each feature in making prediction. I also plot a graph of error versus epoch. If the error decreases over time, it shows that the model is learning effectively. If the error stabilizes, it means the model has converged. So this visualization over here, it helps in understanding the learning behavior of the perceptron. So this implementation shows how the perceptron learns from the data by adjusting weights based on errors and gradually improves classification performance over time. So this is experiment number 4.